So I wanted to show everyone what I've been up to with semantic entity resolution. So I'm going to show you a full run of the process. You can see the commands there. Here I'm going to run, it takes like several iterations since there's a maximum block size. At the moment I'm using 100. It can do 300, but you start to lose IDs more. 100 is really stable. And then I'll try 50 for the parallel Gemini requests. I'm having rate limit problems, so hopefully I won't this time. But I run 3 or 4 iterations before it gets down to from 15,000 companies to dramatically fewer. So I use Spark to block and evaluate because I don't want to be dependent on a database or anything that doesn't scale. Though I'm dealing with tier 1 limits on my Graphlet account since I switched from my personal cloud account. You know, everything I build tends to scale fairly well. You can see the blocks here. They're 829 NVIDIA. This isn't a huge data set. It's something I've extracted from financial news. And now the blocking here isn't semantic. I'm actually just doing a baseline at the moment of company first word and acronyms. So like, you know, like AMD lines up with AMD, and then I am doing the matching semantically using Gemini 2.0 Flash. So here comes the matching. It runs 50 threads at once to do it asynchronously. Hopefully it won't error out. So it's got 6,100 blocks of different company names. You can see all of the debug. It actually literally explains it to you. Without blocking, there would be 255 million company comparisons. There were 15,000 companies input. This is only really high quality news that I'm using. So that's basically the story there. This is for my investment club. We're building a knowledge graph at the NVIDIA. It's dominated data center space. You can see the different type of blocks here. So it duplicates companies when it blocks. So 6,100 blocks, 23,000 companies, and now it's submitting BAML requests. I removed some of the debug output. It used to flood the screen with like lots of requests, and that was useful for debugging. What you're seeing now is like, look, I found a missing ID. One primary ID that went into ND resolution was missing, so it's basically gonna recover that one missing company by adding it back to the output. This is one reason you're using an LLM to match entire blocks of records in this video. So it could be matching a block of 100 NVIDIAs. Let's say it loses one. You can actually see it does say the block usually, but it's not this way. It doesn't lose any records. I duplicate anything that's lost during a connection with the LLM on the output of the job. And if any IDs are lost, I replace those UUIDs from the incoming source record IDs since there are multiple rounds. So there's less than 1% records are lost. You're seeing a few come by. These are not actual like errors in the program. These are just Gemini losing track of a record. And this is the reality of working with LLMs. What's amazing though is that they're very powerful, and I'll show you at the end the graph that this generates. And I mean, this has gone through a lot of sites like SemiAnalysis and data centers, like lots of data center articles, and it basically just boils it down to a single company node per company. So there's one NVIDIA, and that's what I'm going to show you. This is running all the stages. Right now it's running the match step. I had to write a UUID mapper that maps between integers and UUIDs as they go in and out of Gemini. That's something now BAML recommends. They tested it out on me, and then it became a recommendation. So this is all Python and BAML for the matching. Now you'll notice the number of blocks it's submitting is 2,500, not 6,000. That's because it did a group by to define blocks, and some were size 1. So it essentially just skips them and kicks them into the output. That's kind of a hack, but it works well. So you can see the number of companies blocked, processed. It was for 15,000. Hold on, where are the summaries? Total block 6,100. Let's see. Before there were 15,000. Now there are 7,000. That's one round of matching. Over here, the overall pipeline results. And let me show you something cool. Oops. Window work. That's my Japanese lo-fi. This is the end result. This is NVIDIA. There's a single NVIDIA. There's a single Google. There's a single OpenAI, and there were, hundreds of these to start. And this is the reality of semantic entity resolution. I've just gotten the matching to the point where it works really, really well, and I'm about to start my second blog post. Check out the Graphlet AI blog or Towards Data Science to see the first one. It's covered matching in a fairly primitive way in the demo, but I do all the accounting, obviously, using Spark. So all right, yeah, you can see different relationships and their meanings. Let me try to find the primary one. ASTS and MOUs with Intel. It's hard to, let me zoom in. I should filter, but I forget how to use Graphistry sometimes. NVIDIA Corporation and Intel. EdgeNet is partnered with Intel. Oh, that's actually a node next to NVIDIA. Let's see if there's an Oracle deal. Is there a blob storage is used for processing data workloads in the cloud? That's interesting, between NVIDIA and Microsoft. So we just made an inference, and that's what knowledge graphs are for. Thanks a lot.